Okay, I've only got 11 of you at the moment, so I'll just have to keep going. There's nothing I can do about it. Okay, so where were we? So we've got our finite state machine diagram here. We're just drawing it. This is for your side of the situation. The first state that we're going to talk about is the wait for packet 0. You're just waiting to read, if you like. You're waiting to read the first, or you're maybe waiting to squeeze out that first sequence out of the terrorist. And so this, once you get that, once that first character or number in the password comes out the terrorist's mouth, we'll call it RDT send packet. So the event here is we want to reliably transfer. This is the function, reliably transfer this piece of information, this packet of information. So we're going to make a packet. As soon as that happens, we're going to make a packet. Make packet. Let's say, and we'll give it sequence number 0, and we'll put in the data, whatever the data is from this up here. We'll actually change this to data up here to make it easier to look at. So data, which is what we want to reliably send. So we'll put the data inside the packet, and we'll put some checksum on it as well. So we'll calculate some checksum, and we'll include that inside. And we'll just call that packet here x. X equals make packet. That's the name of our packet. We'll just call it x. And then we'll send that packet. So UDT, unreliable data transfer. It's just the name I'm giving this. X. Send that unreliable packet. Those are the two actions we're going to take. We receive something, we want to send it reliably. We're going to make a packet out of it, and we're going to put the data inside it, and then we're going to send it. We're going to use an unreliable data transfer into the channel. So we're going to UDT-X into the channel. And once we've done that, we're just going to stay. We're just going to stay here, waiting for. We're going to wait for AX 0 now. Let's see how we're getting on. 18 viewers back. Okay, not too bad. Bear with me, guys. I'm just trying to make sure I have the right notation here. Okay, so we're going to go once we've created that packet. We're going to move away from this state. We were just waiting for that packet to arrive here, and this is the actions we take. Now we're going to move. I don't want to. Okay. Okay, yeah. Sorry guys, I got ahead of myself there. I just need to rub this out and move it over a little bit. Excuse me. Excuse me, sorry. Wait for packet 0. That's our first message. And this is our very first state. So we're just waiting at this point. Now, the only way to get out of this state is if this event happens. The event is we have something to send. Packet 0 has arrived. We have it to send. So what do? We make a brand new packet out of it. We put a sequence number 0 on the front. We put the data inside that packet, and we put a checksum on the front. And we send it into the reliable channel. And once we've done that, once we've taken those actions, we move over to a new state over here. And in this state, we're going to wait for AC0. Just check you guys are still able to hear me. Fingers crossed. Ah, boy. Yeah, I'm not quite sure what the issue is. I seem to have good bandwidth here at the moment, so. Yeah, I've got really good bandwidth here. So I don't know what the problem is. Maybe there's some way to optimize this for using YouTube. If anyone knows YouTube and how to get the most out of it, maybe let me know. Because I've got an excellent bandwidth here. Okay, I'm going to keep going anyway in the interest of just recording this. So where was I? Okay. Okay. So we're waiting for an acknowledgement to come here. So what are the events that can happen while you're waiting for an acknowledgement? So the first thing that could happen is a timeout, right? So you're waiting and nothing happens. Just make sure I'm still recording. Right. Yeah, great. Okay, so the first thing that could happen is I'm waiting for an acknowledgement and nothing happens. So I have a timeout. So if I'm going to do that, I need to start a timer the moment I send this packet over here. So start timer. So this is action number 1, action number 2, action number 3, start timer. So as soon as I send this packet into the unreliable channel, UDT send X, I need to start the timer. So over here now, if there's a timeout, so if the event here would be a timeout, resend the packet. That would be the event. So the event goes to the top line. The action would be UDT X again, unreliable data transfer X, and start the timer again. So there'll be 2 actions this time, 1 event, 2 actions. And of course, if that happens, I just return to this state and I continue to wait for acknowledgement 0. What would happen if I get a packet? So if I was to receive a packet and it was corrupt, okay? So or I receive the packet, receive X. And X, I check the checksum, and X is corrupt. Then in that case, once again, I send the channel and I start the timer. So I send the thing back into the channel. So either of these 2 cases happen. If there's a timeout, or I receive packet X and X is corrupt, in other words, I use the checksum inside X to confirm that it's not correct, that there's errors in there. Then I resend the packet and I start the timer again, and I just stay in the state here where I'm waiting for an acknowledgement. What else can happen? So another thing that could happen is I receive a packet and it's the sequence number is wrong. So or receive X, and sequence number equals 1. So that's another thing that could happen. If that happens, oh sorry, that would be just do nothing. Yeah, so if that happens, I'll deal with that separately. So I could receive an acknowledgement for the last packet, not the one I've just sent. So an old acknowledgement that maybe took a long time, was delayed or something like that, and it finally got to me. So that'll be a separate situation here. Again, it's going to come back to wait for x0. So I receive x and sequence number not equal to 0, or sequence number equal to 1. So in that case, my action would be do nothing. Just do nothing. So just wait for the time. If there's a problem, the timeout will trigger it. You know, or maybe I receive it and it'll be corrupt yet. Or maybe I receive it and it won't be corrupt. In any case, just do nothing. If I get back an acknowledgement for an older packet, doesn't matter. Just forget about it. We'll deal with this should the rest of the events should cover all the possible events that could happen. So the third event that I'm worried about here, or that I hope will happen rather here, is that I actually get back an acknowledgement. So the event here would be receive x and sequence number equals 0 inside x, and checksum correct, or it's not corrupt. Or maybe I'll just keep the language the same here. And then checksum correct, incorrect up here, and if it's correct down here. So in this case, if this happens, if I get back a packet, if I receive a packet, and the sequence number is 0, sorry, it's not x at all, I'm getting myself muddled here. So I sent x, so I'm waiting for an acknowledgement. Yeah, receive ACK. And then checksum, so there'll be a checksum in the ACK as well. Yeah, UDTX, that's correct. Receive x, receive ACK. Receive ACK and sequence number equals 0. Not equal to 0 rather, or equal equals 1, same thing. And do nothing, wait for the other events to sort it out. Receive. Okay, if you guys can hear me, I'm actually just trying to change the settings. I'm taking some of your suggestions on board here. I'm trying to change the settings on the OBS software. So I'm using a hardware encoder instead of the software encoder. I'm just testing this out, I'm just playing with the settings, so let me know if it improves a little bit, okay? Okay, it looks like it came back, so maybe this is the way to go. I was using a software encoder there, whatever that means. I guess it means I was probably trying to do everything with the CPU instead of using the GPU, I guess, instead of using the hardware. Okay, anyway, let's keep going. Is this better, guys? Just a little bit of feedback would be great. I think it's better. I think there's a bit of a delay here, so might be a minute before you hear me. Video's a lot smoother. Thank you, Carl. Okay, getting better all the time. So I know what to do the next time. Okay, so anyway, over to here now. So we're waiting for packet 1. We've just got a new piece of data. We'll say it does arrive. So we're waiting for packet 1. So what happens? Packet 1 arrives. So same kind of notation as I have up here. RDT. So this is from the this is the event that happens. I want to reliably transfer some piece of data, new data. Here, what are the actions I take? I make a brand new packet, so this time I'll just say x is equal to, exactly the same line as above, make packet, whatever that is, put sequence number 1 on it this time, put my data inside it, and of course calculate my checksum and include that inside the packet as well. Then I want to, so that's step 1. Step 2 would be unreliably send that into the unreliable channel, send that new packet into the unreliable channel, and number 3 would be start my timer. And that's it. So what happens now is I move over to this new state. I hope I'm still inside the page here, yeah, on the board. So my final state here is wait for AC1. And you'll see I'm going to have almost identical situation as I had up here. So once I'm in this wait for AC1, what are the things that can happen? Well, I could have a timeout. So same story as above here. I could have a timeout, or I get an AC1. Timeout is one possibility. Or I receive AC1. I'm just going to write down AC1 this time rather than write down sequence number. Receive AC1. Or receive, or checksum, receive packet, and checksum incorrect. And in that case, I resend the packet. And I start the timer again. So 2 things to do there. The other thing that can happen is I receive a packet and it has the incorrect sequence number. And if that happens, I just do nothing. Receive oh sorry, I shouldn't have put down AC1 there yet. So receive packet, so I leave that one out there. So receive AC1, just do nothing, and stay in this state here where I'm waiting for AC1. Oh, sorry, that should be AC0. So if I receive AC0 and I'm expecting AC1, just stay here waiting for AC1. And then the final thing that can happen, of course, is I actually do receive AC1. And it's not corrupt. What do? Do nothing except move over to this new state where once again I come back to waiting for packet 0. And that's it. It's, in fact, if you look at it, you know, this is exactly how you should behave when you're trying to send those messages to Jared Butler. You wait for the first bit of data from the terrorist, then that comes, we'll say. So what do? You create a new packet, you say 0 and the data to Jared Butler. Okay, it'd be nice if you could do a checksum, but we can't use the analogy completely. So you send it into the unreliable channel to your walkie-talkie, you wait, you start a timer, maybe you look at your watch for 10 seconds, we'll say you give it, and you move over here where you're waiting for Jared Butler to come back with acknowledgement for item 0, for element 0. So, and then once, you know, while you're over here waiting for that acknowledgement, certain things can happen. The first thing is you get a timeout. Second thing is he says acknowledgement for packet 1 instead of packet 0, which means it's an old acknowledgement. You get timeout can happen, or you receive a corrupt acknowledgement, in which case repeat yourself, repeat what the message that you just created over here. So you say 0 on the data and you restart the timer. If you get back an incorrect acknowledgement, say AC1, you do nothing, you just stay here waiting for your acknowledgement, and so on. So what's kind of interesting about this is it sort of mirrors, so everything, so if we look across here, so across here, it's just a mirror image. So everything below the pink line is just a carbon copy of everything below, except we switch zeros for ones. So it's actually quite straightforward. Hopefully this gives you an idea of what finite state machine diagrams are and why they're useful. So they allow us to put all those rules that we've come up with, that protocol that we've come up with for reliable data transfer, into a nice graphical representation. So let's continue on and see if we can figure out what the rules would be on Jared Butler's side, or the receiver side. So I'm going to rub this out. Any questions, guys? Okay, I'm getting good positive feedback here on the quality of the feed. That's good. So it's going to take me a minute to rub this out, and then we'll do the so if you understood everything I just did, it means you can probably answer the questions now. The question threes that I've put up on you'll find in the old exam papers, and I'm going to put up another one this year. Some people think they're hard. If you get the idea, they're not too bad. If you really, it's more about an understanding. You can't really learn off a solution, like people who just pull up a solution from an old exam paper that makes no sense. They just get zero, but if you understand it, you don't need to remember anything. There's only a couple of things to remember. If packets are going to be lost, you need timers. You're going to need a minimum sequence number 0 and 1. If unless you're told. So yeah, I think it's the most interesting question on the paper. I put a bit of effort into it, so it'd be great if more people answered it. So let's see how much time is left. I'll try and do the receiver side of this particular scenario here, and then maybe we'll have a quick look at an exam question if there's time. Let's see, yeah, there might be a bit of time. Okay, so what's the receiver side look like? So the receiver side is actually much simpler. So we're just waiting so Jared Butler is waiting for you to send something. So we just have a simple wait for packet 0 for just sequence number 0. So if a packet comes in and it has so imagine receive X from that has been sent, and not corrupt. In other words, the sequence number is correct. The checksum is correct, not corrupt. And sequence number equals 0. That's great. So do nothing, just move over here. Or should, no, so, yeah, okay, I'll go back to that in a second. So we move over here now where we're just waiting for sequence 1. So we can't move over to sequence number 1 until we have actually received a piece of data that is not corrupt, that has a sequence number 0. Now, of course, we need to deliver this up, so I think I have notation in the notes, just check what the notation is. Okay, so I have notation like this in the notes. Extract. It's a bit close. So extract data from X, and then deliver data up. Deliver data up to the application layer. Remember, on the receiver side of the transport layer, on the receiver side, you're delivering the data. So the data is coming up from the network layer, and then you're looking at it, and then you're passing it back up to the application layer. So deliver data up to the application layer. That's what is meant by this line here. So is there anything else I have here? Oh yes, and of course, once we've received the data, we have to send an acknowledgement. Okay, so make ACK, we call it make ACK. So y equals make ACK, and we put in 0 sequence number, and of course we need a checksum in there as well, so that the receiver, or so that the sender, the original sender, can check that the acknowledgement is not corrupt. We wouldn't want to get an acknowledgement and misinterpret it. So, and then UDT Y. So that would, so this is the action, this is the event that happens. The event is we receive X and it's perfect, and it is sequence number 0. What do? we extract the data out of X, we deliver that data up to our application on the other side of the socket, then we create a brand new packet to acknowledge, an acknowledgement. We put 0 in there for acknowledging 0, and we put in a checksum so we can check errors on the other side, and then we send that acknowledgement into the unreliable channel. And as we do all of this, we move into a new state over here where we're waiting for sequence 1. And of course, the exact opposite would happen on the way back. So if we want to get back from wait for sequence 1 to wait for sequence 0, it's exactly the opposite. The event would be, again, it's just a carbon copy of all of this. Just switch the zeros for 1. So we receive X, and it's not corrupt, and sequence number equals 1. So that's the event that happens. One of the actions we take, exactly the same as all of this here. So extracts the data. From X, deliver the data up to the application layer, make a new packet for it to acknowledge, make packet with sequence number 1, and we have to put in a checksum value so we can check for errors on the other side. And then UDTY. So exactly the same. So like you don't have to remember much really if you are trying to remember this, because you only have to remember half of everything, you know. This covers this. It's exactly the same. You just switch the 0 for the 1. What other events could happen here? Are we still okay here? The connection. Okay, good. So everyone's happier with the connection. Okay, I'll watch out for that for next time. Where was I? Okay, so what are the other things that could possibly happen? Yeah. So there's a few possibilities here. So another thing. So while I'm waiting for sequence number 1. So let's say I managed to move over here. While I'm waiting for sequence number 1, I could receive a packet with the wrong sequence number, which means it's a duplicate of an old one that I already received. Maybe they sent it again because they thought I lost it. They didn't get my acknowledgement. So I need another situation here where I've got receive X, and its sequence number equals 1. Well, what do I do? Nothing. So just do nothing. Just wait. Just sorry, at sequence number 0. So if I'm waiting for sequence number 1 here and I get sequence number 0, it means I've just been sent an old packet that I already received. So I do nothing. And I just come back and wait for sequence 1. The other thing I could do here, rather than do nothing, just to speed things up, I can send back the same acknowledgement I already made here, which was the Y here. So I can just resend my previous acknowledgement. Just say, look, I already acknowledged that. So so I can send back. I'd come back and wait for 0. The other thing I can do is, or the other thing that can happen here is, I receive a packet and it's corrupt, and I just don't know what it is. And again, I'm just going to come back to the same state. So receive X and corrupt. So do nothing. Just come back and wait. Let the timeout on the other side trigger the action to resend. And that is it. So I just put these same two guys over here, and that's the end of the receiver side. So receive X and corrupt. Just do nothing and wait. And then of course if I receive it and it's the wrong acknowledgement number, receive X and sequence number equals 1. What do? I just resend the previous acknowledgement, UDT Y. And that is it. Okay, let's see if we can get a quick exam question in here, unless anyone has a question. No questions coming in? Great. Alright, I'm going to try and find a quick exam question here and put it up, so bear with me. Okay, the audio should be back now. Let me just get this. Okay, so let's go through the question. Consider the following scenario. Actually, you just read that while I rub out the board here. Just give me a minute. Okay. Okay, where were we? So consider the following scenario. At some node or, a high-level process generates requests for data items that are stored at A. And A has loads of these things. So it always has something to send. So nodes or and A are connected by a channel that can lose or corrupt messages, but will not reorder messages. Okay, so design a protocol that operates at or and A such that we have reliable data transfer. Okay, so you've been given a couple of commands there that you can use. Deliver data deliver data is used what's the request protocol, or eventually delivers a requested data item to the layer above, satisfying such a request by calling deliver data. Yeah, where data is the data. You can assume that a call from above will not be made until the previous call has been requested. So this is a perfect example of the 0-1, the 0-1 sequence numbers being sufficient. So OR sends request messages to A. The fields in the request messages are part of your protocol's design. You should design a protocol with which OR requests and A sends data items and that OR delivers to the caller above. Okay, so let's just go through this really quickly because I've only got 10 minutes left. Yeah. Okay, just switch back to the whiteboard. Bear with me. Okay, so I think I've said you have to do both the sender and the receiver. Okay, so let's go through this really quickly. Okay. Okay, so the idea is you have some node OR over here, and it sends a request message over to A. A has loads of data, so you send a quick request message over here, and then once A receives the request message, it sends the data over here. Okay, so that's the idea. So this is the request comes from OR in this direction, and the data comes back from here. Okay, so so the first state we need here is wait for a request 0 to come from the application. So remember, the application is triggering all of this. So this is in the transport layer. It's just there to serve the application. So we wait for request 0 from the application. So the application is going to every now and then knock on the socket door and say, I want to get some data from A. So this is our very first state here. We're just waiting for our request 0. Once that request 0 comes from above, so I should maybe just say from above here. When I say from above, I mean the application layer. So request 0 comes in. That's the from above. That's the event. What do? So we make a little simple packet. So send. Didn't give you any names for these things. No. Okay. I'll just use simple names. Send request 0 into the unreliable channel, or UDT send. You were told your channel could lose or corrupt. So if it can corrupt, I need a checksum. So I'm going to have to go and do the same thing I did a minute ago. I'm going to have to make a packet. Let's call it X. It's very similar. X equals make packet. Give it a sequence number 0. We don't need any data. It's just a simple request. And we need to put in a checksum to make sure it's not corrupt. And then UDT send X into the unreliable channel and start our. Do we need a timer? Yeah, we need a timer. You're told you can lose. So if you're told it's going to lose packets, then you need a timer. If you're told it can corrupt packets, then you need checksum. Simple rules, right? So start timer. And off you go to this state over here where you're equating. Oh, now at this point you're waiting for the data. So now you're waiting for A to send you the data. So this is a pull protocol as opposed to a push protocol. So you wait for data 0 from A. You probably hear my kids coming home from school. Wait for data 0 from A. So what can happen while we're waiting here? Well, hopefully we receive the actual correct data. So if we receive the data, if that event happens, receive data, and it has the correct sequence number of 0, and it's not corrupt. Then we can move on. We do nothing. Once we receive the data, we need to deliver. That was the one thing you were told: deliver data up to the application layer. So what do? We deliver data to the application layer above, and that's it. And we move down to wait for request 1 from above. So once we've received it, remember what you were told in the question, you won't receive another request from above to pull more data from A until the previous request has been satisfied. So at this point, it has been satisfied, so now you can wait for new data. Wait for request 1 from above. What else could have happened here? Well, while you were waiting for the data, you could have experienced a timeout. That would just mean come back, right? So timeout. You would just resend your request, UDTX here. Start timer. I'm sure there's any questions coming in. No questions coming in. The feed looks a lot better now. Just looking at it here, it's a much smaller delay. Where was I? Oh yeah, what else could happen? We could also receive data that's corrupt. So if we receive data that's corrupt, we can just do nothing. So if we receive data from A, but it's corrupt, then do nothing and just save here. So what will happen in this case is eventually the timeout will occur, and then you'll resend the request. So you don't need to write that down again here. So if you receive something that's corrupt, just do nothing and let the timeout take care of it. What else could happen? You could receive data, but it has the wrong sequence number. In which case you just repeat your request again. So receive data and it's 1 here. So or receive data 1. And then if that happens, just repeat your request. So either of these two events, you do the same thing here. And that is the end of that. I mean, once you get to here, it's just a carbon copy, right? So you just repeat everything along this diagonal line, and you get the full protocol. So that's the bit for the sender. So it's pretty straightforward. You saw me do that in 5 minutes, and that's like nearly a full question in the exam. So it's that level. It's that level of if you're able to reason it out pretty quickly. Now this was a simple enough example. I've been forced to come up with more detailed examples to try and make them different. But I mean they're similar-ish. So if you can come up with an answer like that very quickly, you get full marks essentially. What was the second part? Do the receiver side, was it? Yeah, okay. So you were asked for 7 marks to the receiver. So for 1/3 of the marks, do the receiver side. But the receiver is even easier. I might even be able to draw it down here. Okay, so the receiver side down here, you just got one state where you're waiting for request 0. Wait for request 0, let's say. And once you receive request 0, send data. So the event here would be receive receive request 0 and not corrupt. What do? Well, then you send, so you make packet, you make a packet, so x equals make packet data, put your data inside it, and put the sequence number 0 on there, and put a checksum in there as well. And send it. UDT send x. Do I need a timer? No, I don't need a timer on the receiver side. If there's any problem, if it's lost, I'll get a repeat of the request. Remember, we had a timer up here for the request. So if this is lost and the receiver and the sender, or the requester in this case, doesn't get the data, then it's eventually going to just time out and send the request again. And of course I come over, so this event would lead me over here to a second state where I'm just wait for OR1. And that's it, carbon copy. So you just repeat this line here with ones for zeros down here and you're done. And that is it. If you were to get a request for OR1 while you're waiting for OR0, just do nothing. So if the event is you receive OR1, let's say, just do nothing and just wait here for OR0. And similarly over here, if you get a request for OR0, just stay here. And that is it. That is the end of that question. So I did that question in 5 minutes. And I will leave you there. It's 4 o'clock. Thank you to how many people have stayed with me? Nobody in the room. So it looks like I've dropped again. Okay. Okay, we'll leave it there, guys. Oh, I didn't drop. Okay, that's weird. But unfortunately it looks like I stopped recording for some reason today. Anyway, we'll leave it there, guys. I'll upload whatever I've recorded and I'll chat to you soon. Okay, take care, guys. Thanks for sticking with me, all 16 of you. Take care, bye.